This is Srinivasa Tirunagari. I'm a technology professional having 34 plus years of experience. Right now, I'm a freelancer since 2012. Earlier to that, I was with Cognizant as a principal consultant ERP, and I'm also a corporate trainer. I train employees of Oracle Corporation as well as Microsoft and other vendors such as Cyan Technologies, etc. I have expertise in big data, Hadoop ecosystem, Python, Core Java, SQL, PL/SQL, MySQL. I'm a frequent blogger and presenter on different blogging environments. So this is all about myself, and today I'm going to give a demo on big data and Hadoop ecosystems. So let us begin. What is a data? First of all, in order to understand what is big data, we need to understand what is data. So introduction to big data, and so first of all, we need to understand what is data. According to Oxford Dictionary, the data is defined as the quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. So data is, in fact, in short, we can define it as raw facts or EW raw facts. One moment. So this is the definition given by the Oxford Dictionary. So one moment. So data, in simple terms, data can be defined as raw facts. If I say some numbers, say 55, 46, 23, and then 67, 89. If I write some number, few numbers, it doesn't convey any meaning actually. As it is, data doesn't convey any meaning. But if you ask a question, what are these numbers? These numbers are, I can say, marks obtained by a student in 5 subjects. Okay, then you get some information and you have some meaningful data or meaningful information. So you can ask another question: what is the average mark? And you can sum up these numbers and divide by 5. You will get the average mark. And what is the total marks? You will get the total marks. So as it is, these numbers doesn't convey any meaning. So in other words, they are nothing but raw facts. Okay. So data is nothing but raw facts, or as per the definition, it is the quantities or characters or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals. So this is a technical definition of data that is given by Oxford Dictionary. So, so big data is also data, but with a huge size. When you say big data, is also some sort of data, but with the size of the data is very huge in the sense you cannot manage on a single machine, you cannot store it, and you cannot process it using a single processor or single machine. So big data is a term used to describe collection of data that is huge in size. Okay, it is nothing but it is used to describe the collection of describe about the data or collection of data that is very huge in fact, huge in size, and yet growing exponentially with time. So what is happening here? The data we have collected the data, and it is the size is very huge, but also the data is growing exponentially with the time. So data is increasing, and data is huge in size. Okay. In short, such a data is so large and complex that none of the traditional data management tools like RDBMS tools are able to store it or process it efficiently. So once we store the data, for example, you take your mobile phone, you store the data, you store the telephone numbers and names of your friends and relatives. Okay. But the size of the data is very small. Okay, and in the case of big data, the data is very huge, very large, and it is also complex. Complex in the sense it is not defined, it is not structured, it is unstructured or semi-structured or what you say, structured. Both all the three things. It is a complex one. So we have tools right now available to process the data, traditional data, that is structured data, using RDBMS tools. For example, Oracle, IBM, DB2 from IBM, SQL Server. So they process the data, a finite amount of data, structured data. But these tools are not able to store huge volume of data, and they cannot process it efficiently. Okay, then in that case, we can say that it is big data. The term big indicates that a huge volume of data. So if you look at the diagram, the how huge big data looks like this, and it is growing exponentially along with the time. As the time progresses, the data also increases, and we cannot manage it traditionally. The traditional tools cannot manage to process and store the data. Examples of big data. Let us take some examples. So you take New York Stock Exchange. It will generate about 1 terabyte of new trade data per day. So such a huge volume of data it is generating, and so this is an example of big data. Another example is Stacks 500 plus terabytes of new data gets ingested into the database of social media such as Facebook. So approximately 500 terabytes of data is ingested into the database of the social media site in the form of movie clips or video clips, then pictures, then messages, etc., etc. So 500, approximately 500 terabytes. It is more nowadays, and it gets ingested into the social media such as Facebook and Twitter. So see how much, what is the volume of data it is getting into the system. And another example is the jet engine can generate 10 plus terabytes of data in 30 minutes of flight time. So approximately 10 terabytes of 10 terabytes of data uh, is generated within this span of 30 minutes of flight time. So assume that how many hours a flight can fly, a jet engine will fly, and how many flights are there. So with many thousand flights per day, generation of data reaches up to many petabytes. So the data is measured in the form of bytes, kilobytes, KB, MB, GB, then TB, terabytes, and petabytes, PB. Like and zettabytes is also there. So these are some of the examples of big data. So let us see the categories of the big data. What are the different types of big data? So big data could be found in three forms. One is structured data. I'm going to explain what is structured data in a short while. And then we have unstructured data, And structured data, in the case of structured data, the data is defined and it has a pixel length of size and no, it is structured actually. So how many columns, how many fields are there? But in the case of unstructured, there is no definitive fields or columns and column size. So it is unstructured, such as unstructured data could be your movie clips or video clips, pictures and messages, etc. And semi-structured, some data is structured and some data is unstructured. So in that case, we call it as semi-structured. So big data could be found in three forms. One is structured, another is unstructured, and third one is semi-structured. Uh, Let us see what is structured data. Any data that can be stored, accessed, and processed in the form of a fixed format is known as structured data. So, in the case of structured data, the data is being stored and accessed and processed in the fixed format. Then we can say that data is structured data. Let us take an example. Over the period of time, talent in computer science have achieved greater success in developing techniques for working with such kind of data. So if you look at the present databases, they are all structured. So the organizations are using RDBMS, Relational Database Management Systems, and these RDBMS are from Oracle, uh, IBM, and SQL Server from Microsoft. These are three major gains which take most of the share in the market. However, nowadays we are forcing issues when size of such data grows to huge extent, and typical sizes are being in the range of multiple zettabytes. So what is a zettabyte? 10 to the power of 21 bytes equal to 1 zettabyte, or 1 billion terabytes forms a zettabyte. So this is the conversion. So a zettabyte is equal to 10 to the power of 21 bytes. Okay. And we have data of few zettabytes generated every day. In few examples I have shown you. So these are the data. So you take Twitter or Facebook, and 500 plus terabytes of data per day is a huge data that is ingested into the systems. So looking at these figures, one can easily understand why the name big data is given, and imagine the challenges involved in its storage and processing. So when you have the data, you have to store it at some place. We have to store it, and once we store it, we have to process it. You have to process like you want to insert the data, you want to modify the existing data. Sometimes what happens, say for example, you have employee details, you have salary details. So based upon the performance of the employee, you give the increment or you give the bonus to the employee. So that information should be added to the database. So we modify the existing data, we increase the salary for that given employee. Okay. So we modify, we update. We also delete the data that is no longer required. So the example of structured data is data stored in the relational RDBMS system is one example of structured data. So let us take an example of structured data. Let us take employee. Organization consists of employee. Employee has certain property attributes like name of the employee, first name, last name, and he also has ID, employee ID, and he has salary, and then he has department, manager ID, etc. So look at this example. Employee ID, and we have employee name, gender, department, and salary in lakhs. So this is the information is recorded and stored in the database. So employee ID is 2365, and his name is Rajesh Kulkarni, and the gender, he is a male. He works in finance department, and his salary is 6,50,000 per annum. And another employee, 3398 is the ID, and Pratibha Joshi, her name is Pratibha Joshi. The gender is female, and she works in admin department. Her salary is also 650,000 rupees or dollars, you can say. Like that, we record all the employees in the organization. So this is a structure. So if you look at the employee ID, there are only 4 digits for the ID. So this is structured, and employee name consists of, let's say for example, 50 characters or 60 characters. So you define what type of data and what is the size of the data for this employee name, and similarly gender, department, and salary is number type data, and department is like it is a character type data or var 2 like that. And employee ID is also number. The size of the employee ID is maximum 4 digits. Okay, so you define before you store the data, and we store the data in a table. In the RDBMS, we call it as a table. There is a space where you store the data, and we can process it. We can I mean, you can retrieve the data. So the processing takes place. So these are the things you can perform. Say you get the data, select the data, and retrieve the data or retrieve the information. Select is the one command, and then before select, you insert the data into the table. After insert, you select and then you modify or update or modify. And sometimes what happens, an employee changes to other department. So in that scenario, you modify the existing record. So say Rajesh Khanna, for example, he is right now working in finance and he moves to admin department. So you have to modify this record. You have to update because I don't have to reinsert the data because already data is there. So I just have to change this department name. So that we got as modification or update. Sometimes we may have to delete the data, delete that is no longer required, or we archive, in fact, in real-time scenario, we archive the data. Okay, this is an example of, classic example of structured data. Okay, any questions you have? Okay, all right. Unstructured data. Any data with unknown form or the structure is classified as unstructured data. So here in unstructured data, there is no specific definition of the data or size of the data. So in addition to the size being huge, unstructured data poses multiple challenges in terms of its processing for deriving value out of it. So once you store the data, we have to process it and to derive the value from that. So unstructured data poses a lot of challenges because first thing is we have to store. It is very huge in volume, and we have to store it, and we have to process it. Okay? So once you process the data, you get the meaningful information, or the data is you can take the organization can take a decision based upon the information. So typical example of unstructured data is a heterogeneous data source or mixed data type. Heterogeneous means containing a combination of simple text files and images and videos, etc. That is unstructured data. Nowadays, organizations have wealth of data available with them. So, but unfortunately, they don't know how to derive value out of it. They don't know how to process it. Since this data is in its raw form or unstructured, format. So for example, examples of unstructured data, output returned by Google search. So look at this. Suppose if you search for Hadoop big data, you get all this stuff. This is a screenshot actually. So this is like unstructured data. Some videos you get, some PDF documents you get in the output of this Google search, and some videos, and then some blocks, some text information, textual information you get. So this is uh, example of unstructured data. Then we have semi-structured. Semi-structured data can contain both the forms of data, structured as well as unstructured. We can see semi-structured data as a structured in form, but it is actually not defined with a table definition in relational DBMS or DBMS. Example of semi-structured data is the data represented in XML file. For example, it looks like this. Personal data stored in XML file, say for example. So this is an example of XML file. So this is here, the data is structured as well as unstructured. Okay. So this is a classic example of semi-structured data. So XML file represents structured data as well as semi-structured. So let us see what are the characteristics of the big data. So first one is volume. Okay. Second one is variety of data. You have pictures, you have videos, and you have textual data, etc. And velocity. The velocity is with what speed the data is entering into the system. Okay. So say 500 terabytes of data per day, or a few hundreds of terabytes of data per hour, or so that is the speed at which the data is entering into the system. We call it as velocity. It is one of the characteristics of big data. And variability. Variability means we have different kinds of data that is entering into the system. And these are the four characteristics of big data. Finally, I want to add one more thing: value. Value of the data. So fifth one is value of the data. So what value we can generate out of the data. So that is also important. We have data, tons of data, tons of information, but what value it has. Okay. So we require only the meaningful information. So in order to get the meaningful information, we process the data. Okay. So the value is also one of the characteristic of big data. So let us see the volume. The name big data itself is related to the size, which is enormous or huge in volume. Size of data plays very crucial role in determining value out of data. So also, whether a particular data can actually be considered as a big data or not. So based upon the volume, you can determine the so whether you can give it a name as big data or not. Okay, it is dependent upon volume of data. So hence, volume is one characteristic which needs to be considered while dealing with the big data. And next one is variety. So the next aspect of big data is its variety. Variety refers to heterogeneous sources and the nature of data. We have different sources of data entering into system, and the data is also doesn't belong to one type of data. It is in the form of textual files or textual data, and then we have video clippings, etc. And it can be both structured and unstructured as well as. So during earlier days, for example, you take spreadsheets and databases were the only sources of data considered by most of the applications. We used to have spreadsheets. Of course, today also we have spreadsheets and databases. Okay. But the database has a limitation to store the data. We use NAS or network assisted storage or SAN. Okay, so these are two different types of storage mechanisms, SAN or NAS. And variety, second one is nowadays data in the form of emails, photos, videos, and monitoring devices, PDFs, audios, etc. is also being considered in the analysis applications. Okay, so these are the varieties of data that is entering into the system. We will analyze. So this variety of unstructured data poses certain issues of for storage, mining, and analyzing the data. Then velocity. Third characteristic is velocity. The term velocity refers to the speed of generation of data, with what speed the data is entering into the system. How fast the data is generated and processed to meet the demands determines the real potential in the data. Big data velocity deals with the speed at which data flows in form from sources like business processes and application logs, networks and social media sites, and sensors, mobile devices, etc. The flow of data is massive and it is continuous or streaming. So we call it as streaming data. And variability. This refers to the inconsistency which can be shown by the data at times. So which hampers the process of being able to handle and manage data effectively. So value is the fifth one is value. So what value? So you invest in the data storage and processing of the data, etc. So what value you derive based upon the data? That is the fifth one is fifth characteristic is data value. Okay. And what are the benefits of big data processing? So it brings multiple benefits such as businesses can utilize outside intelligence while taking decisions and improve customer services and early identification of risk to the product or services if any and better operational efficiency. So these are the some of the benefits of big data processing. Okay. Now we have seen what is data, what is big data, and what are the characteristics of the big data, examples of big data, etc. But the challenge is how to store this data, huge volume of data that is being generated every day, some few zettabytes of data every day, and it is entering into the system. The challenge is how to store the data, and once you store it, how you can process within an optimal time. Okay? So the solution to this challenge is Hadoop. Hadoop is basically a framework. It is an open source software and it has been designed in Java and it is open source, meaning you can download the software, you can install it, and you can read the source code. And if you want, you can make changes to the source code, etc. So that is the meaning of open source. It is an open source Apache Foundation, or it is an open source free and library. So it is open. I mean, it is free, and you can download it and you can use it. So in order to store the data, so Hadoop is a framework. This Hadoop is installed on the top of Linux machine, Linux operating system. So Hadoop you can consider as operating OS to some extent, but it is a framework wherein on top of Linux. So we have a distributed file system, Hadoop distributed file system. So we have file, the data is stored in the form of files and that is stored on Hadoop. We call it as HDFS. And then we have yarn. Yarn is to process the data. It is yet another resource negotiator. We'll see what is yarn. And MapReduce, we have mappers and reducers. So wherein a job, you write an application, you design an application, and you execute those programs, what will happen? Those those things are broken down into smaller tasks, and each task is being processed, and the results are summed or aggregated in the reducer section. And uh, so we call it as MapReduce technique, mappers and reduce. In the MapReduce, what will happen? The task is broken down to subtasks, number of subtasks, and each subtask is processed parallelly, and the output of each process subtask is aggregated, and then we call it as reducer. Okay. So then we have another language or a tool to design the application is Big Latin. Of course, Java is the prerequisite. Java, you should have knowledge in Java so that you can design MapReduce programs. But some people they do not have this Java uh, programming knowledge. In that case, Big Latin comes into picture. Like with the Big Latin, uh, this is a tool where you can design programs with ease and efficiently. Suppose if you write a program in Java, say 100 lines of code in Java for a given application, for a given requirement, but in Big Latin you can achieve the same within less than 10 lines. So the learning is you can learn with ease. It is very easy to learn Big Latin. Of course, the environment is big and the language is Big Latin. Okay? So I'm going to uh, give an overview of these things today. Okay. Hadoop HDFS overview. Hadoop distributed file system. HDFS means Hadoop distributed file system. So somebody asked a question. Of course, I will be uploading to the Google Drive so that you can download it. I will be sharing the slides. Once you enroll into the class, I will be sharing these slides. Okay. Just now, I'm going to share after the class. So once you enroll, you will get all the slides. Okay. Any more questions here? All right. So Hadoop HDFS stands for Hadoop Distributed File System. It is the world's most reliable storage system, and it is a file system of Hadoop designed for storing very large files running on a cluster of commodity hardware. Commodity hardware means inexpensive hardware. So we don't require expensive hardware to store the data. So we have a cluster of a commodity hardware. We have a bunch of commodity hardware, inexpensive hardware. So we can store very large files which are running on this commodity hardware. And it is designed on principles of storage of less number of large files rather than the huge number of small files. So this is a concept. Instead of having a huge number of small files, you have less number of larger files. So then processing becomes very easy and efficient. Hadoop also provides fault-tolerant storage layer for Hadoop and its other components. Say we cannot give guarantee like whenever a cluster in the cluster a node fails due to some reason. Okay, in that case also your data is available to your application and processing can take place without any failure. So we call it as fault tolerant. So HDFS provides fault tolerant storage layer for Hadoop, and we discuss in detail when we take up this. So this is the second chapter, and HDFS replication of data helps us to attain this feature. How you can achieve this fault tolerant? So what will happen? A file is being stored on the HDFS in a particular node in the cluster, and that is replicated into another node. So we have at least minimum 3 copies of the data, so in different nodes. So if one node fails, then other node is taken care by, and your processing will not stop. So that's why we call it as fault tolerant. What would be fault tolerant? So it stores data reliably even in the case of hardware failure. If one node fails, the data is stored in another node. It provides high throughput access to application data by providing the data access in parallel. So that is the advantage of Hadoop HDFS. So we have nodes actually, HDFS nodes. We have it works in the master slave fashion. So HDFS has two types of nodes that work in the same manner. So one is a name node, another is data node in the cluster. So we have name nodes, we can have more than one name node, and we can have one more than one data node. So it looks like this. So master node, on the left hand side you have master nodes, and on the right hand side you have slave node, or in other words it is data node. So master node stores information about the slave node. In what node a particular piece of information is stored, what file is being stored, where it is stored, how it is stored, etc. Or that information is stored, that we call it as metadata. It is stored in the master node. Name node regulates the file access to the clients, and it maintains and manages the slave nodes and assigns tasks to them. So name node basically maintains and manages the slave node or data nodes. Okay, and name node executes file system namespace operations like such as opening a file and closing the file and renaming the files and directories. So these are examples of name node. And slave node, also known as data node. There are a number of slave nodes or data nodes in Hadoop distributed file system, and these manages the data storage. If you want to store the data, you store the data in the data nodes. So these slave nodes are also known as actual worker nodes. So they store the data, and they're also known as data nodes or actual worker nodes. They do actual work. You process the data here in data nodes. So these slave nodes do the tasks and serve read and write requests from the file system's client, and then they also perform block creation. So I am going to explain what is a blocks creation in a moment, and deletion of the data, and replication upon instruction from the name node. So the name node will instruct the slave node. Say you replicate the data 3 times or 4 times, you can configure it. The user will configure it how many times the data should be replicated. So based upon that, the master node instruct the slave node or the data node to replicate. Okay. And block is like where it is a unit of storage uh, in Hadoop. So normally in a regular file system, we have a block size of 512 bytes, a block consisting of 512 bytes. That means data is stored in blocks consisting of 512 bytes. But whereas in the case of Hadoop, in HDFS, the block size is minimum by default it is 128 megabytes, MBs, 128 MB of size. So we have huge 128. So it depends upon that is a minimum by default. So based upon the requirement, you can increase the block size. So once a block is written on a data node, it replicates it to other data node and process continues until the number of replicas mentioned is created. Okay. So data nodes can be deployed on commodity hardware, inexpensive hardware, and we need not deploy them on very reliable hardware. That is one thing. And we have daemons, HDFS daemons running, processes running on this master node as well as data node. There are two daemons which run for HDFS for data storage. One is name node, another is data node. And Hadoop HDFS daemons. Name node, this is the daemon that runs on all the master nodes. And name node stores metadata like file name and the number of blocks a file can take and number of replicas, how many times it should be replicated, and that means replication means copies of the same data and location of the blocks in the data node and block IDs, etc. And the name node, the metadata is available in memory in the master for faster retrieval of data. In the local disk, a copy of metadata is available for persistence. So you have a local copy of the metadata. Metadata consists of block location and file name, etc. So name node memory should be high as per the requirement. And then we have data node daemon. This is the daemon that runs on the slave. These are actual worker nodes that store the data, and this is all about HDFS overview. You have any questions here? Okay. So yarn is yet another resource negotiator. So all the aspects of about Hadoop yarn like yarn introduction, yarn architecture, and yarn nodes and daemons, resource manager and node manager. So these are the components of the yarn. So this is the resource management layer of Hadoop. Yet another resource negotiator. Yarn stands for yet another resource negotiator. It is the resource management tool of the Hadoop. And this yarn was introduced in Hadoop 2.x. Now that we have Hadoop 3.x. So yarn allows different data processing engines like graphical processing and interactive processing and stream processing as well as batch processing to run and process data that is being stored in HDFS. Resource management is a tool, actually. It is a piece of software uh, wherein we have resources like we have name node and data node. We have to manage those things in order to, once you design the application, so you have to run the job, you have to run the application in the uh, different modes like interactive processing. You are doing some interactive processing or stream processing. So the application should know where the data is resided and where from the data is coming from. Okay, we have to have a uh, resource manager where which will manage the resources. So it will have the information on blocks and files, file names, directories, etc. So this yarn is another resource negotiator is nothing but a resource manager which manages the resources. We have different nodes. We have data nodes. We have name nodes. Okay. Uh, it is installed in the master. Apart from resource management, Yarn also does, it also do, you can also schedule the jobs. Two resources will be there in Yarn. Yeah. All right. So it also extends the power of Hadoop to other evolving technologies. So they can take the advantage of HDFS, which is the most reliable and popular storage system on the planet and economic cluster. Okay. This is all about Yarn. Is just I have given an overview of Yarn. And then we have MapReduce overview. It is a core component of Hadoop and it processes huge amount of data in parallel by dividing the work into a set of independent tasks. So the main task is broken down into smaller tasks which are independent. Okay, and each independent task performs parallelly, and it processes huge volume of data. In MapReduce, data flow is step by step from mapper to reducer. So in MapReduce mechanism, we have two things. One is mapper, another is reducer. In the mapper, what will happen? The task is broken down into subtasks, and all these subtasks are executed parallelly. And the output of these subtasks are aggregated or summed in the reducer, and finally you will get the results. So reducer will give you the result by aggregating the results of subtasks. So we will be learning various phases of MapReduce job execution such as input files and then input format in Hadoop. What should be the format? Input format file and input splits. Then we have record reader. Once we read the file, so in the form of well, a line is ready from the file, and we call it as a record. So record reader and mapper here combiner, partitioner, shuffling and sorting, and reducer, record writer. Finally, you write the data into another file once you process the data. So using record writer, we write the data and output format in detail. So these are different phases of MapReduce job execution. Okay. So now the question is, what is MapReduce? We can define it as it is a data processing layer on Hadoop. MapReduce is a program. Basically, you design the program or you design the application in Java. So either it can be designed in Java or Python. So it is a software framework for easily writing applications and which process the vast amount of structured as well as unstructured data that is stored in the HDFS. How this map reducer works basically, as I told you that it works by breaking the data processing into two phases. One is map phase, another is reducer phase. Okay. So the map is the first phase of processing and where we specify all the complex logic or business rules or costly code. And reduce is the second phase of processing where we specify lightweight processing like aggregation and summation. This aggregation summation from the mappers. So these are the input files. So I will skip this. Pig Latin. So Pig Latin is it is Apache Pig is abstraction of over MapReduce. And basically it is a tool as a platform which is used to analyze large sets of data representing them as data flows. We call them as data flows. Okay, so Pig is generally used with Hadoop and we can perform all the data manipulation operations in Hadoop using Pig. It looks like SQL. If you are familiar with SQL, so say for example you want to extract some data, okay, you want to filter out some data, so those things are performed with ease. Okay. Pig Latin is a language, high-level language. It is provided by Pig, and this language provides various operators using which programmers can develop their own functions or for reading the files, writing into files, and processing the data. Okay, so I will stop here for today, and if you have any questions, we'll take up questions and answers. Any questions? All right. What is the prerequisite for this class apart from Java and Python? If you know the programming language Java, that is good. Even otherwise, of course, Hadoop uses Big Latin too. Yeah, it is good to have this knowledge on Java and Python. Okay, so when I deal with the MapReduce programs, MapReduce concept, I am taking examples in Java. Okay, the exams are designed in Java. Also, you should have a prerequisite like the knowledge in the basic commands in Linux. You should have that knowledge also. Okay. So once you enroll in the class, probably I will take a couple of classes for reviewing the basic commands on Linux as well as Hadoop. So the program looks like this. Okay. One moment. The program looks like this. Say population.csv comma separated value. This is the file where data is stored, and you load the data using pig storage, and the comma indicates that the data is separated by comma, and you store it in population. This is one command, and population is going to load the data using pig storage as so it consists of this data. Population consists of. So this is the year, and this indicates the number of people. I mean, yeah, and one indicates male or two indicates female. So this is the population count. Okay, this is the age group. So the data looks like this, and you load the data into a variable, and these are the columns or the fields: year, age, gender, and population size. All are integers. Okay, I'm also specifying the data type of that field. The first column is year. Here it is. These are all numbers or integers. Second column is also age. It represents age. It is also number or integer. Third one is gender. It is also represents in the form of numbers. So it is integer again. So when I load the data, I also specify this: year, age, gender, pop size. These are the columns actually that are not mentioned on uh, in the file, original file. So I want to filter out some population by age is equal to 50 and gender is equal to 2. So I want to extract the data. Uh, uh, the age group is 50 and all the females. So I want to filter out the data. Once I filter out, I will get everything in here, and dump is the command and to dump the results on the monitor, or you can write it down to the file. Okay, any other questions? So this is a small pig Latin program, and we can write such programs with ease. Okay. Any other questions? Yeah, very simple. Looks like SQL actually, SQL. So there are, we can say that this is a fourth generation language. So what to do, how to do, there are two things. What we mention when you write an application or a program, we specify what to do and how to do. These two things we specify when you design a program. In Big Latin, simply mention what to do. How to do is taken care by the big. Yeah, it is structured. Yeah. Of course, you can work on unstructured data as well. All right. I will. I'll stop here. And if you have any other question, let me know. Okay then. Thank you very much, and have a great one. Uh, thank you. Bye bye.